All right, so today I'm going to ask you to take some notes on multiplying decimals. So go ahead and title your page, Multiplying Decimals. Now, there's 3 different ways that you can multiply decimals. And they're all very similar, and they'll all get you the same answer. I'm going to show you all 3 of them because I think that it's good for you to have different ways to do things. So, the first one I'm going to talk about is called the estimating method. And in my opinion, this is the quickest and easiest one to do. Though you, of course, may feel differently than me because we have different brains. So let's say that we have the numbers 2.4 times 3.61. Well, as some of you may remember, whenever you multiply decimals, you multiply using the whole number version of the decimal. And all that means is that we just pretend like there isn't a decimal here. If there was no decimal here, this number would be 24. So we're going to start by multiplying 24 times, if there was no decimal here, this number would be 361. So we're going to multiply it by 361. 4 times 1 is 4. 2 times 1 is 2. Next line, placeholder 0 because we're multiplying by 60. 4 times 6 is 24. Carry the 2. 2 times 6 is 12. Plus 2 is 14. Next line, 2 placeholder zeros because we're multiplying by 300, which has 2 zeros. So 4 times 3 is 12. Carry the 1. 2 times 3 is 6, plus 1 is 7. 4 plus a bunch of zeros is 4. 2 plus 4 plus 0, that's 6. 4 plus 2 is 6. And 1 plus 7 is 8. Now, that of course is not our final answer. And I say of course because look at these numbers to begin with. 2.4 times 3.61. There's no way that can be 8,000 anything. And I say no way because 2.4, if I estimate, is pretty close to 2. And 3.6, if I estimate, is pretty close to either 3 or 4. About 4 here, rounding up, 5 or higher, but 3 or 4. Either way, it gets you to a number that's pretty much 8. Right? So 8,000? So where do I need to put my decimal in my answer? Right now, the decimal is here because there's always an invisible decimal after a whole number. So 8,000, nope. 866.4, nope. 86.64, still not close to 8. 8.664, that's close to 8. Let's double check the last place just to make sure. 0.8664. 0.8 is less than 1, so not close to 8. 8.664 sounds like the best option. So that is where our decimal place goes. Now we have an answer that makes sense. This answer, 8.664, is close to 8. Awesome. Estimating can get you to the point where you can place the decimal in your answer. All right, the next method we're going to talk about is called the place value method. And the reason it's called that is because it depends on your knowledge of place values. So remember yesterday we talked about how all of our numbers are in base 10. And what that means is that every place value is like multiplying a 10 or dividing a 10. That means that 2.4 is the same exact thing as 24 divided by 10. Because when we divide by 10, we're taking that invisible decimal and moving it over 1. 24 divided by 10, you just move that decimal point over 1 to 2.4. 3.61 is equal to 361 divided by 10, and then divided by 10 again, which is the same thing as dividing by 100. But I'm going to write it this way. So if we divide by 10 once and then twice, we get to 3.61. So let's say we do that same whole number division or multiplication that we did before. 24 times 361. We get the same answer, 8,664. But this time, instead of estimating, we can divide by 10, divide by 10, divide by 10. Because that's the part we were leaving out when we used 24 times 361 instead of these numbers. So divide by 10, divide by 10, divide by 10. The first time we divide by 10, we take this invisible decimal and we move it once. Taking care of that one. Now we take this invisible decimal and we move it again for the second one. And a third and last time for that last divided by 10. This gives us the final answer of 8.664, which is the same answer we got up here with the estimating method. That's super cool. Now, our third method is called the counting method. And I know a lot of people who really prefer the counting method. So I'm going to put it over here. So I'm just going to draw a line around all this. The counting method, shockingly enough, involves, yep, that's right, counting. So we know that we have how many numbers to the right of the decimal place. Let's count. We have 1, 2, 3 numbers to the right of the decimal place. So when we do our whole number multiplication, 24 times 361, and get our answer of 8.664, or 8,664, I should say. We know that we need to move our decimal, this invisible one at the end again, 3 times. 1, 2, 3. So it ends up right here. And we end up with that final answer again of 8.664. We moved it 3 times because there were 3 numbers to the right of the decimal. All 3 of these methods get you to the same point where you put your decimal right after the 8 because it's close to 8, and we know the answer should be close to 8 because we divided by 10 3 times. Because there's 3 numbers to the right of the decimal. These are all really great ways to multiply decimals. You just turn your decimals into whole numbers and multiply like normal, and then you can use any of these 3 methods to get to your final answer.